So Josh walks 15 meters per second and runs into a standing still Justin. So Josh is walking 15 meters per second, standing still, and the velocity. As Josh thought he was walking closer to a mirror. If Josh and Justin have the same mass, so their mass is the exact same, and Josh moves backwards at 3 meters per second, it's important to know it's backwards because that means he'll be negative. After the collision, how fast does Justin move? Okay, so I'm going to draw a picture of Josh and Justin. So here's Josh, and here's Justin. And Josh is going to run directly into Justin. So Josh has a velocity of 15 meters per second. And then it says Justin has a velocity of 0 meters per second. Notice it doesn't tell us the mass, but it tells us something about their mass. It says they have the same mass. Okay, when a problem does that, it tells you they have the same mass. It usually means you can either cancel it out or you can just make up a number. So whatever number we make up, as long as it's the exact same for both of them, it does not matter. So let's say, just for fun, let's say they weigh 700 kilos each. They're pretty tall, right? So 700 kilos, that's like 1,500 pounds. So they weigh 700 kilos each. And now I'm going to draw our little diagram to help us out. So for our diagram of our picture, we're going to have initial, so this is before Josh runs into Justin, and then our final, so this is after Josh doesn't realize he's just running straight into his brother instead of a mirror. So here is Josh, 15 meters per second, 700 kilograms. Notice they have different velocities for the initial, so I need to make sure that we put a plus sign in between. Now we have 0 meters per second for Justin and 700 kilos again. Notice their masses, remember, have to be the exact same. Now we're going to move on to the final. It says Josh moves backwards at 3 meters per second, so I'm going to draw Josh. I'm actually going to draw Josh in a different color. The reason why is because his velocity is going to be different. So I'm going to actually draw him in orange. And so he's going 3 meters per second. Notice he's going backwards, so it's actually going to be negative 3 meters per second. And he's going to keep his mass. It's asking for what Justin's velocity would be. So I'm going to have to draw another picture so we can solve for Justin's velocity. So if he has a mass of 700 kilograms, we're going to be looking for that velocity that he is traveling at. So real quick, I'll write down our givens, unknown, and equations. So givens, we're going to have mass is 700 kilograms, velocity 15 meters per second. Now I'm going to move on to our next picture. 700 kilograms is our mass. It looks like all of them are 700 kilograms. Velocity is 0 meters per second. I'm going to move on to our orange picture. Mass 700 kilograms. Velocity is negative 3 meters per second. Remember, it's negative because it's going backwards. Mass for the fourth object, 700 kilograms. And we are looking for that velocity, so I'm going to put that under our unknown. We are looking for the blue velocity, and that would be the velocity of Justin. Now what we need to do is find our equation. So remember, between objects you put addition signs, and when this line splits, the initial and final, you should put an equal sign. So we're going to have a mass and velocity plus a mass and velocity equals mass and velocity plus mass and velocity. Notice the velocities are not the same in any of these. that we know of. So if you go over to the right, in black are our equations. This has mass and velocity plus mass and velocity equals mass and velocity plus mass and velocity. Okay, so that one looks pretty good. Notice the second one has a final velocity that's the exact same. Notice our final velocities are not the same, and so we cannot use that. The third one, it says their initial velocity is the same. We definitely know that is not true, so we cannot use 2 or 3. So we're going to stick with equation number 1. So I'm going to use that equation, and I'm going to color code it real quick. So we're going to put mass, velocity initial 1. So I'm just literally copying it from this picture. So it's going to be plus the green one, which was M1 VI2 equals, now I'm going to do the orange one. Last one you should know is going to be blue after we write the orange one. This would be the mass. I'm sorry. That should have been mass of object 2. This would be mass. You could do of object 3, it really doesn't matter, but I'm going to do, just because we know this one was Josh, so this one was Josh. Not that it really matters because their masses are all the exact same, right? So I'm just going to make it a third object, so mass of object 3, and then final velocity. You can do final velocity of 3 if you want. Remember, subscripts are just for your benefit. That's all they're really for. And then blue, mass 4, VF 4. Based off of this and this up here, you should know what our unknown is. We also say it right here is going to be the blue velocity. And then also if you look at the question after the collision, how fast does Justin move? So that's what's boxed. That's what we're looking for. So we're looking for this final velocity in blue. So what we're going to do to get it by itself, PEMDAS backwards. So we're going to subtract this first and then divide by M4. So we're going to have, when we sort it, we're going to have M1 VI1 plus M2 VI2. And then we're going to subtract. Remember, we're subtracting and then dividing. We're going to subtract the orange and then divide by the blue. M3, VF3. And we're going to divide by M4. And this is going to equal our final velocity. If you want to put 4, you can. It's just final velocity of the blue object, though. So our last portion is just substitution. We're just going to substitute in from here. So we're just going to take the red, we get the numbers from here, so it would be 700 kilograms. Velocity of red would be 15 meters per second. Plus the green object, 700 kilograms. Velocity is 0 meters per second. Now we're going to subtract. So we're going to subtract mass is 700 kilograms. -3 meters per second is the velocity. And now we're going to divide by Justin's mass, which was 700 kilograms. So we're going to get 18 meters per second. Notice it's going to be positive, so that means Justin's going to be moving forward, Josh is going to be moving backwards. Also notice kilogram is in every single term, so we can cancel it out. But with that, it's 700 kilograms, so technically you can actually cross out the 700s too. Right here, right here, right here, and right here. They're all going to cancel out. That's why it doesn't matter what their mass is. As long as it's the same number and not 0, it'll all work out, and you'll get 18 meters per second.